Here we go. Sawyer, Kaylee B. Kaylee B. Sawyer. Good morning, everybody. Please open up that PowerPoint for today. Please open up that PowerPoint for today. Carter is here. Isabella is here. Brandon and Bridget. Good morning, everybody. Annie and Courtney. And Courtney. Hi, guys. While you're joining, I would love for you to open up the slideshow for today. Open it up to that first, warm up for today. It says number talk. And Diego. And Gabby. Okay, and we're gonna get started. Let's take a look at what we're doing for today. Actually, I'm not sharing my screen, so that's why you can't see what I'm doing. Let me pull up the participant list over on my other computer. Let me pull up my chat on my other computer. And let's get started. So I want you to right now, for yourself, I would love you to take 1 minute right now to find the value of each product mentally. So you're working without using a calculator, and you are going to be calculating the product of each one of these multiplication problems. You're taking 1 minute right now, and put those answers in your slideshow, or if you have your textbook, in your textbook. Billy is not here either. What is going on? Was Billy here earlier, guys? Let me know in the chat. Was Billy here earlier? Okay, we're taking about 26 more seconds. Thanks, Carter. Thanks, Avery. Kyle is here. We're taking about 1 more second. Okay, ladies and gentlemen, let's take a look at this number talk for today. It says find the value of each product mentally. 2 times 15 times 2. What did we get for a product of this one? Throw it in the chat for me. That's like saying 15 times 2. You can think about it that way. Multiply, multiply, add them together. Or you can think about it simply as 2 groups of 15. 15 plus 15 is equal to 30. Very good. Nice job, guys. 30 is equal to 15 times 2. Awesome, awesome job. Very good. Now we're looking at 15 times 0.5. 0.5 means the same thing as 1/2. So we're looking for half of 15. What's half of 15, guys? Nice job, Avery. Ethan, I think that's the next one, my friend. Sawyer, fantastic. It's going to be half of 15 is 7.5. We know that if we think about it, 15 is close to 14, right? Half of 14 is 7. And then 14 plus 1 more gets me that 15. Half of that is 0.5. So 7 plus 0.5 is 7.5. That's a really complicated way of doing it. I mean, that's how my brain sort of does it because that's how my teachers sort of taught it to me. I don't know if your teachers really taught you many of those mental math strategies. I know that that's not like the most in right now in teaching. So I just wanted to sort of visualize for you how I did it. I broke it down into 15 is equal to 14 plus 1. Half of an even number is 7 plus 7, plus half of that 1 is 0.5. Add them together, 7.5. Okay? I'm sorry, I know that was sort of convoluted, but I thought that you guys could sort of handle that. Okay? So now we're looking at 15 times 0.25, which is like saying half of a half. Half of that half. So if I'm looking at that 7.5, I need to break it in two. I have 7, right? Which can be broken into, it can be 7 is equal to 6 and 1. So that's 3 and a half. Plus that 0.5 can be broken into 0.25. Add it in 3.75. Literally, it's not just 3.5, it's 3.75. So this one right here, I would say is probably the most challenging. I would sort of expect you guys to use a calculator for that one because like this is like a way to do it, but it's like sort of complicated. So then the last one, 15 times 2.25. What did we get for the product of that last one? I know I'm sort of just talking a lot today. What did we get? I got Avery's answer. I need a
33.
Go ahead, Diego.
33.75.
33.75. Very good. So we can
Because.
Oh, go ahead. Go ahead. No, go ahead.
I said because it's in the parentheses. So.
Good. So we have to multiply. We could say the same thing as multiply 15 times the 2, 15 times the 0.5, and we already have both of those products here. We have 30 and we have this 3.75, right? So we can add them together to get that total product of 33.75. Okay, so the mental math sort of idea here is to show you that when you're dealing with a puppy like that puppy, if you will, you can sort of break it down into two separate pieces here. You could look at it as 15 times that whole number plus 15 times that decimal so that it's a little bit easier for you, okay? This doesn't really have anything to do with what we're doing right now. I mean, we're going to be doing some multiplication, so that's going to be important. But this was sort of just to get your brain ready for today. Okay? Learning targets for today is I'm talking about creating graphs. Okay? We need to scale and label a coordinate axis in order to graph a proportional relationship. Oh my gosh, there's a lot here. That's a lot. Okay. So what does it mean to scale a graph, you guys? I don't remember. Miss Jermaine is like a little bit dehydrated. Her brain's not working today. What is it scale a graph? Go ahead, Diego, or whoever that was, Avery.
No, that was me. Okay. I think it means to take the plotted points from like the scale and plot them down and turn them into fractions.
Okay, so before we can even put points on our graph though, we need to name, so we're looking at our axes here and they're blank, they're naked. We don't want naked axes. Not fun, not looking good. We have to give them a name. So for example, if we're talking about minutes and miles ran, these two names here, the names on our axes are called labels, okay? When we scale our axes, that means we're going to put numbers down. So 1, 2, 3, 4, 5, 10, 15, 20. So scaling is when you number your axes, and label is when you name them, okay? When you give them a name. So when you're talking about miles and minutes, that would be your label. When you're talking about your scale, that's when you number the axes, each of the lines on the axis, okay? And when we're talking about a proportional relationship here, ladies and gentlemen, a proportional relationship means one of two things. First, a proportional relationship means it starts at 0, 0. On a grid, it hits your origin. It goes through your origin. Second thing is that it has a constant of proportionality. Okay, a constant of proportionality is basically the same thing as a constant rate of change. So when you're looking at a proportional relationship, it goes through that 0, 0, and it has a constant of proportionality or a constant rate of change. Okay, so we're going to be graphing some proportional relationships today, remembering to scale and label our axes. Okay. You're going to be doing one in class with me, and you're going to be doing one independently at home today. Okay. So if we look at in your textbook, you're looking at 3.2. If you're looking at the slideshow, you're on slide number 5. Okay. And it says, here are 2 ways to represent a situation. We're given a description and we're given an equation. Okay. And the description is basically like a story problem written out for you. Okay. An equation has our rate of change in our 2 variables here, x and y, okay? So let's look at this description. Let's read the description together, okay? So the description says, Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, so let me give you a little bit more for this, okay? So Jada and Noah are walking to the band room, walking to the band room from the art room. Okay, so they're walking from the art room to the band room. When they're walking from the art room to the band room, it takes Jada 8 steps to get there, and it takes Noah 10 steps to get there. What do we know about Jada and Noah? Now, who can tell me something that we know? Go ahead, Avery.
Well, they're walking 2 different steps. Jada's walking 2 steps less than Noah is.
So that means maybe when they're walking, you can't really see, but like maybe Jada is taller. I love it. I love it. It's not necessarily talking about speed because it's not saying it took Jada 8 seconds and Noah 10 seconds. It's talking about the number of steps. So it's really talking about like how big is their stride. Like if it was me, I would be more like Jada because I walk big steps, right? So like, let me sort of move my camera down so you can see what I'm talking about. So like the amount of space in each step is larger for Jada, right? So Jada's taking larger steps. Noah's like taking some little dainty ones, like small little steps. So they're walking the same distance, but Jada is like taking bigger steps. Okay, that wasn't like the most important thing to point out, but I just wanted to, I like it, Carter. I like it. Fantastic. So then when they walked to the band room, and then they were like, I need to walk back up to team. So then they found that when Noah took 15 steps, Jada took 12 steps. So Noah took 15 and Jada took 12. Okay, so we're going to use this information and this equation here to answer some questions. So the equation says that X is going to represent the number of steps Jada takes and Y is going to represent the number of steps that Noah takes. So when we think back to last year, when you learned about constants of proportionality, so constant of proportionality, that's your rate of change, right? And in your equation, the number that's attached to your X is your constant of proportionality, or another word we use for it is slope. So I'm going to circle it right here. So this is your constant of proportionality. Constant of proportionality is written as, like I said yesterday, Y over X. In this scenario, Y represents which person? Looking back up here at the description, Y represents
Jada.
Look that up in Jada.
Oh, wait.
No,
Noah.
Y represents Noah. Very good. So it's going to look like Noah over what? Noah over X, which is Jada. Very good. Nice job. So your constant of proportionality is written as Noah over Jada. So if you're looking at this constant of proportionality, what's another set of steps that they could have taken? How many steps, if you're looking at this constant of proportionality, did Noah take? Looking at that constant of proportionality, knowing that the numerator is Noah, how many?
Noah took 5.
It would be 5. Very good. Let's get ready to throw those in the chat though, okay? And then how many steps did Jada take? Looking at that constant of proportionality, the numerator represents Noah, the denominator represents Jada. How many steps did Jada take?
4.
Nice job, Jada. Nice job. 4 steps. So when Noah took 5 steps, how many steps did Jada take? Nice job, Avery. Nice job, Jaden. She took 4 steps, okay? So now we're gonna use these points to create a table. So now on your slideshow, I want you to look at the next slide. If you're in your textbook, it just has this piece written down and there's no table. So if you're working in your textbook right now, I need you to draw this table in for yourself because it's not in there. Okay, but you can if you want to. If you want to just work on the slideshow, please feel free to do that. Okay, I personally think it's a little bit better to work on the slideshow, but that's just me. Okay, so we need to find some points for Noah and Jada here. So let's start with, if Jada walks 0 steps, how many steps does Noah take? Bridget, how did you know that?
Because you have to start on the 0, 0 axis.
Very good. And when you plug 0 in for X, 5/4 times 0, it's going to be is equal to Y. Y is going to be equal to 0. Nice job, Bridget. That's fantastic. You used your context clues, what you know about proportional relationships in the context of the story to answer that question. Very good. Okay, so what's another coordinate pair that I can make for Jada and Noah? What's a set of steps that we can take here? Kaylee B, help me out. Kaylee B, why don't you unmute and let me know what's one set of steps that Jada and Noah could take? Nice job, Avery. Kaylee B. What do you think, Kaylee B? Oh, perfect. I'll come back to you in a minute. Okay, Kaylee B? So Avery, actually Sawyer, can I have you on mute because I haven't heard from you today? Sawyer, what's one set of coordinate pairs that we could do for Jada and Noah?
We could do 4 and 5.
Very good. So he was a little bit soft there because my volume was turned down. He said Jada takes 4 steps, Noah takes 5 steps. So when Jada takes 4 steps, Noah is going to take 5 steps. Very good. Jaden Ramos, can you help me out and can you give me another set of points that I can talk about when I'm talking about Jada and Noah? I put them together. What do you think, Jaden? Why don't we use one of the sets? That's a good one, Jaden. But let's use one from the story. We had some more sets on the last slide here. What were some more sets of points that they walked? Very good, Jaden. Another set. I don't know where we're getting 8 and 10 from. 8 and 10 is not correct. Another set was when Jada walks 12, and Noah will have walked 15. Very good. Nice job there, Jaden. And then the last step, when Oh wait, no, you're right. 8 and 10 is 1. I don't know what I'm talking about. Sawyer said, or Kaylee B said 8 and 10. Who has 8 in this scenario, Kaylee B? You said 8 and 10, but you didn't tell me who is who.
Jada has 8 and Noah has 10.
Very good. Nice job. Carter, you can go ahead to the bathroom. Not a big deal. Jada has 8 and Noah has 10. Very, very, very good. Nice job, my friends. Fantastic job. So now we are going to use this table. We're going to use this table to make a graph of this data. So what I'm going to do really quick is, because I can't flip back and forth, I'm going to write my data over here. Jada and Noah. While I'm writing this down, please make sure that you have this written in your table for yourself. Okay. Let's take a look at this guy here. Okay, so it says we need to, in your textbook, it also says this for you. Graph this relationship, label your axes. Label and scale our axes here. So we need to label our axes. And what did we say label meant? What do we have to do? Nice job, Avery. We'll test that one when we graph, okay? So what do we have to do when we label our axes? We have to give our axes what? Labels. Yes, we have. Go ahead.
A point.
Nope, we're not lit. We can't put points on yet because look, we have naked axes. No, we don't want those. No, we need to have.
Oh, you gotta label them. Yeah, my bad.
Numbers, right? Just like Jaden said, we have to name them. So I want you to take 1 minute right now to name your axes, okay? I want you to name them, and then if you finish early, I want you to start to number them in those boxes, okay?
Miss, do I put the name of the axes on the little boxes on the outside?
You put them in, you put the name in here, like if you do like Jada or Noah, you would type it in here, and then the numbers get typed in these boxes right here. That makes sense?
Okay. Yeah.
So you're taking 1 minute. If you finish naming them, I want you to start to number them or scale them. Okay, awesome job. Let's take a look. When we're looking at this x-axis down here, so this guy down here, what was the name that you gave the x-axis on this graph? Let me know in the chat. Would you give it? Lily, what'd you name it? Give it, or what'd you name it, Lily?
I named it Jada.
Nice job. This one is going to be labeled Jada because if you look back to here, it said X represented Jada. X represents Jada. Good. Nice job there, Lily. Now, if we labeled that X-axis Jada, what would we name the Y-axis? Nice job, Jaden. Nice job, Courtney. Awesome job, Avery. It would be labeled Noah. Very good. Noah is going to be labeled as our Y-axis. Very good. So now let's think about scaling. In this box right here, what number do I have to put? Always starts at, that represents our origin. So what number goes there? Nice job, Avery. Nice job, Courtney. Nice. Oh, Nice job, Jaden. It's going to be a 0. Very good. Because our origin represents 0, 0. So we can put a 0 there. You can't forget to label your 0 on your graph here. Okay? So that means like when you're writing in your textbook, you can't label it like 0 here. 0 always comes, or no, you can't like put like 2 here. Like you can't start with 2 on this line right here. It has to start with 0. Okay? So we have 0 on our x-axis here. We're going to go by 2s. 2, 4, 6, 8, 10, 12, 14. Okay? If you need to add another box on the end, that might be a good idea. Now we're going to jump by actually 2s here. So each line is going to be worth 2. So it's going to be 4, 6, 8, and then we're going to say 10, and then we're going to say 12, then we're going to say 14, then we're going to say 16, 18, 20, and then I'm going to stop at 20, okay? So if you look at the way that I wrote these, the ones that I wrote in green are the ones that you're going to type in these boxes. The ones that I wrote in red, you're not going to necessarily need to write here. I'm just writing them so that we can know where those numbers fall, okay? So the green numbers you're going to type in the boxes, and the red numbers are just there so that we know what those lines represent, okay? So I need to plot some points on this graph here. Who can help me plot some points? Where am I going to plot a point? If we look back at our table of Jada and Noah, where's one of our points going to go? Nice job, Carter. Please fill in everything that we have here. Scale and label your axes. Help me out, Miss Button. Miss Button, I haven't heard from you in a while. What's one of our coordinates here?
4, 5.
4, 5. So that means I'm going to go over to 4 and up to 5. Is that what you're saying?
Yeah.
Perfect. So I'm going to grab this guy here. I don't know if I still have it in my hand. Go over to 4, up to 5. So 5 is going to fall in between here. See, I didn't really have it in my hand. Over to 4, up to 5. Kaylee B, how you doing over there? Very good, Carter. Carter, can you tell me one more? Unmute yourself and can you tell me one?
Can you hear me?
Yeah, I can hear you.
All right. 1 is 8, 10.
8, 10. So that means I'm going to go over to 8, up to 10. Very good. Nice job, Carter. Wait, I didn't actually grab one. Sorry. Over to 8, up to 10. Very good. And Avery, can you tell me one more?
12 and 15.
12 and 15. Very good. So I'm going to grab this. I'm going to go over to 12, up to 15. 15 is going to sort of fall in between a box. So now I have some points that are labeled here. I need to connect them using these, using the line feature here, which to get that line to connect them, you're going to come up to the bar up here. You're going to look at this line with the 2 little dots on the end of it. You're going to click it. Okay. And you're going to start at the 0, 0 because we know that's where our line is going to start. And you're going to draw a line that goes through each one of your points. It's like a little bit off for some reason, just because like some of our points aren't the best. But we're going to draw in the guesstimate of our line here. And this is what our line is going to look like. So on your graph, you should have 2 things here. You should, or actually a bunch of things. You should have your points and you should draw in your line connecting them. Okay. And remembering that it's not always like mine. Oh, because the reason this isn't right is because this is.
How do I get a line?
So the line is up here, Diego. When you come up into this bar up here, it says it has like a line with like 2 little dots on the end of it. You click it, and then you put a point at 0, 0, and you draw it out like that. Okay. And I went over 1 too many for this. That's why that didn't line up. Boom. Okay. So you should have this graph all filled out for yourself. Okay. So I'm going to leave it up for a second for you to get it all figured out for yourself. Tomorrow, we are going to be talking about and doing this discussion at the beginning of class tomorrow. So where do you see your constant proportionality in a table, a graph, and an equation? We're going to talk about those tomorrow after you do this activity right here. Okay? So I want you to, for this afternoon, you're going to look at slide number 12. 12 has a LinkedIn video for you. Okay, so I still have half the people in this class not watching the videos and doing the activities. The activities and the videos are worth, for this week, they're worth quiz grades. So they're going in PowerSchool as 50s because they're not done. So you need to go in and you need to come to this slide here and you're going to click on cohort number 3. It's going to take you to the Edpuzzle video. Let me just get.
After, are you able to go back to the slide with the line on it, like the graph?
Oh yeah, give me 1 second. And it will take you to this video right here with me going through the slides for you. So you click it and you go along with me, pausing when I tell you to pause, okay? So you go through and you are doing this activity right here, following along with our video. That is what your activity is for this afternoon. Let me pull up the slide for you again with the graph. Does anybody have questions for the expectations of this afternoon?
Do we do the rest of the work up until slide 12, then the rest, or no?
No, so you're just gonna start at slide 12. I'm gonna go through the rest of that stuff for tomorrow at the beginning of class. Good question, Avery. So you don't need to do anything before slide 12. You're doing 12 to the end, using the video, those videos to help you. Okay? So there's a few friends also that only watch like 50% of it. You need to make sure that you're watching the whole thing so that you can do the whole activity for yourself. Okay? There's a few friends that I'm going to be emailing this afternoon that I haven't had watch videos on Monday or Tuesday. So please check your emails. This afternoon, I'm running a session, a Zoom session from 1:30 to 2, where you can come and just do the work with me. Ask me questions if you have them. Please feel free to join that if you'd like. That's going to be posted on the class stream as well. Okay. Awesome job today, ladies and gentlemen. You guys can head out to science if you don't have any questions for me.